Hello, welcome back to my channel JBTeguihanon Engineering and Chemistry Tutorial. Please join me as we continue our study for the refrigeration system, and now our topic is a survey of refrigerants. A survey of refrigerants. Refrigerant is very crucial, very important to the refrigeration system simply because it is the blood. It's like a blood of the refrigeration system. Most people describe compressor as the heart of the refrigeration system, as that of the human body. So is the refrigerant is like a blood of the human body. So let's jump in a bit of history. So first refrigerant use was uh, employed by Perkins in his hand-operated vapor compression machine. So I have gone through this earlier in these subjects, but I wanted to repeat it from different materials. Okay, and then ethyl chloride. This is C2, no? C2 H2 chlorine, right? That is ethyl chloride was used as refrigerant, which soon gave way to ammonia in 1875. Okay, about same time as sulfur dioxide in 1874, and then we have methyl chloride in 1878, and then carbon dioxide in 1888, and then also, yeah, they are found application as refrigerants. During 1910 to 1930, many new refrigerants such as N2O3, CH4, C2H6, C2H4, and C3H3 were employed for medium and low temperature refrigeration. And then we have also the what we call uh, halocarbon. Halocarbon were used also, however, found extremely inflammable. And then dichloromethane, this is CH2, Cl2, and then dichloroethylene, this guy here, C2H2, Cl2, and mono monobromethylene, CH3 Bro, Br, were also used as refrigerant for the centrifugal machines. Of course, a great breakthrough happened um, or occur in the field of refrigeration with the development of Freons, a trade name, in 1930s by DuPont Del Minor and Company. Freon series of fluorinated hydrocarbons, generally known as fluorocarbons derived from the methane, ethane, etc. as bases. Okay. Let's move forward to the next slide. And then we have these, yeah, fluorine, essentially fluorine, chlorine, and some bromine in their molecules were formed a series of refrigerant ranges of normal boiling points and or saturated temperature at some atmospheric pressure to satisfy the varied requirement of different refrigerating machines. So the presence of fluorine in the molecules makes compound non-toxic and impart other desirable physical and physiological characteristics. Planck has given individual treatment to some 50 organics, inorganics, and organics refrigerants, and many more have been listed. Among the most common inorganic refrigerants are these are inorganics, ammonia, NH3, no? NH3. This is used with reciprocating and screw compressors in cold storages, ice plants, right? Food refrigeration, etc. And then we have also used H2O. Actually, H2O has a boiling point of 100 degrees Celsius, which is disadvantage compared with the other modern day refrigerant because of their characteristic which of the boiling point which is low compared with water. So anyway, water was used, lithium bromide absorption system, and steam ejector system only for air conditioning. Okay, and then we have carbon dioxide, CO2, used as solid carbon dioxide or dry ice, frozen food, transport, refrigeration. Okay, let's move to the next slide. And then presently, of course, the most common, what you call it, most common, commonly used organic refrigerants are chlorofluoro derivatives. This is CH4, okay, and CH26, right? CH4 and C2H6, H6, right? So this guy here, okay. So the fully halogenated ones are chlorine in their molecules, okay, are this one, chlorofluorocarbon, referred to as CFCs, those containing H atoms in the molecules along with chlorine and with Cl and F atoms, referred to as hydrofluorocarbons. This is HCFC. The one here, the first one is fluorocarbon, CFCs. All those having no chlorine atoms and the molecules are hydrofluorocarbons or HFC. And then we have the hydrocarbons, HR, right? This is HR. Thus, we have It says HFCs, it's CFC, then CFC. We know that CFC and HCFC are identified with high COP refrigerants with many favorable properties like non-flammability, low toxicity, and material compatibility that led to their widespread use as refrigerant because this is very important. Low toxicity, very important for safety aspect. And even the low flammability also. Low toxicity is important for health hazard, and non-flammability is important for safety hazard. Okay, and then lead to their widespread refrigerant. So the most common organic refrigerant that have been employed in recent times are this one, R11 or CFC11. Sorry, R11 used with centrifugal compressor in large capacity. CFC, yeah, and sorry, CL3F. And also, of course, this is used for central air conditioning plants. Then we have refrigerant 12, 2. This is used for the reciprocating compressors in small units. Of course, it is called CFC12. This is the chemical formula carbon, chlorine 2, and F2. Used especially with refrigerators, water coolers, etc. Then we have R22, used in reciprocating compressors in window type air conditioners and large units such as package units and central air conditioning plants. It is also used for low temp refrigeration applications such as cold storage, food freezing, storage, etc., with reciprocating and often screw compressors. Okay, the chemical formula is this one, ClF2. They call it HFC, HCFC22. So we have CFC11, CFC12, and CFC22. Okay, okay. We have here the last slide, and then we have the yeah, we have C2, CL3, F3. Okay, and then we have uh, what we call this one. We have this refrigerant 11, sorry, refrigerant 114 or CFC 14, 114. And the chemical formula is this guy here, C2, Cl2A4. So it is used with rotary compressors, right? With rotary compressors. And then we have refrigerant 142B, okay, 142B, and then, yeah, we have the um, this guy, and it is used for heat pump and high condensing temperature application, and also refrigerant 502 for a large supermarket frozen food cabinets involving high pressure ratio application. So the atom and the molecules of this substance came or makes the substance physiologically more favorable. Okay, the Cl atom in the molecules is considerably responsible for the depletion of ozone. So if we, you know, analyze this, the formula, chemical formula is this guy here, carbon 2, Cl2 and F4 for the refrigerant 114. So what he's saying is that F atom, the atom here, no, the atom in here, this guy here, okay, is a substance that is more favorable. This is more favorable. However, the Cl atom depletes the ozone layer, the Cl atom, fluorine. Okay, this is in the upper atmosphere, no? What we, they call stratosphere. So, thus allowing harmful ultraviolet radiation to penetrate through the atmosphere and reach the Earth's surface. So the Earth's atom, like in this formula, there is an Earth's right, atom. And the molecule imparts degree of flammability substance depending upon the number of these atoms. So these are the things that we need to understand so far. Okay, so far. So that's all for now. Thanks for watching. Kindly subscribe to my channel. Those of you who have not yet subscribed, God bless for now. Bye.